Hi everybody, this is a showcase of my postdoctoral research where we will utilize the new buzz technology, artificial intelligence, which includes machine learning, to try and answer some very pressing questions in order to manage some of our most economically important fruit pests more efficiently. My name is Bekker and my host is Professor Pia Addison. This project is motivated by the need for basic information to optimize our way of monitoring our pests, and because monitoring data is crucial for machine learning analysis, which opens up our ability to plan ahead and enable predictions. The objective will be to answer 4 questions. Firstly, what is the optimal trap layout for fruit fly population estimation within an orchard? This information will improve the efficiency of our fruit fly monitoring and give farmers a guideline of how many traps they should set out and in what configuration, in order to have the most accurate picture of their fruit fly population. Secondly, is there any spatial temporal relationship between fruit fly trap catches and fruit damage? Here we revisit the old question of can fruit fly traps give an estimation of fruit damage? However, now we will incorporate the spatial scale at which we will conduct fruit fly monitoring and fruit damage assessments. The scale aspect has never been considered in previous research when attempts of finding a relationship between trap catch and fruit damage was conducted. Thirdly, which fruit fly morphological feature or group of features can be used to make accurate automated IDs of adults and larvae of a group of species within the genus Cerathitis and Bactrocera? This will improve our capability of making accurate, faster identifications, but it will also fill the resource gap in the necessary insect taxonomy field. And lastly, which biotic and abiotic factors drives the spatial temporal distribution of codling moth at orchard level? This will give us insight in how we can manage our orchards more effectively in terms of timing of crop protection measures, but also future orchard planning, for instance, where to plant new orchards. The overall aim of this project is to supply the industry with information in order to improve the accuracy of fruit fly monitoring and identification, improve the estimation of crop damage due to fruit flies, and understand why certain orchards are codling moth hotspots and others are cold spots. Just note that a large part of this project has been severely influenced by restrictions on movement due to the pandemic. Therefore, very little information can be given in terms of results. However, progress on each question will shortly be discussed. But let's first briefly look at the materials and methods. So for question 1, we will work in different fruit orchards, setting up different trap configurations and then releasing sterile male medflies and monitoring trap catch every 24 hours, assessing and comparing the recapture rates for each configuration, and through that determine the most sensitive configuration. For question 2, we will work in pair orchards, trapping medfly and cape fly. According to trapping radius of each lure, we will set out traps and conduct monthly monitoring and fruit damage assessment within these radiuses over an entire fruiting season. We will then compare these values to see if we find any relationship between the trap catch and fruit damage. For question 3, we will take numerous images of fruit fly wings and conduct image analysis together with machine learning in order to determine unique features and separate the wings into different species. For question 4, we will collect on-farm codling moth data at orchard scale. We will set up a spatial database, also known as a GIS, into which we will import all relevant biotic and abiotic data, including remotely sensed data. Using spatial analysis, we will determine which orchards over a number of seasons are hotspots or problem areas and which of them are cold spots, non-problem areas, and then use machine learning to classify or explain these hot and cold spots. In answering these questions, new tools in the form of machine learning, which is a form of artificial intelligence, will be utilized together with traditional statistical methods. In terms of progress, for question 1, this trial will be conducted in the coming season at the Welgevallen Experimental Farm in Stellenbosch, where there are a variety of fruit types which is necessary for this trial. For question 2, a pilot trial was launched for this question in the end of the season during February 2020 on 2 plum cultivars, Ruby Star and Flavor Fall. However, due to lockdown restrictions, the data was incomplete. This trial will now commence in September 2020 in pair orchards. For question 3, with the help of an engineering MSc student, we are collaborating in developing an automated trap which can also take the necessary pictures in order to conduct the automated IDs for the Cerathitis and Bactrocera species. Please see an image taken by the trap camera on the slide. When testing the modified bucket trap using DDVP as a killing agent, Flies that were spending too much time within the underside funnel actually died before they could enter the trap. This should be further explored, as it suggests that perhaps the traps are giving false negative readings due to the flies never getting the opportunity to enter the trap. For question 4, all codling moth data per orchard from our study site has been collected and cleaned and imported into our spatial database. All other relevant data will now be collected and sourced, after which analysis will commence. Please see some descriptive maps on the slide. Given that still a lot needs to be done to answer our questions, this coming season is going to be busy. I would like to thank Wardgrove for making the funding available to research these questions, which we believe will supply the industry with valuable crop protection information. If you have any questions or would just like to discuss my project, you are more than welcome to contact me on email or WhatsApp to arrange a meeting virtually, or if we can, meet face to face. Thank you.